Ooh, was this page 356. Yeah, there it is. Okay, hey, welcome everyone. Page 356 at our choosing. Let's go. We're going to look at the time as we start talking about arc degree measurements. We're going to use that beautiful, wonderful thing on the wall, the clock, to tell us the time because it's a circle. And if you think about how many degrees there are in a circle and how many hours there are portrayed on the clock face, we can do some really good math with that. Recall that the degree measure of a circle is 360 degrees. Man, if you forgot 360 degrees is a circle, where have you been? Each minor arc of a circle is associated with and determined by a specific central angle. And I've seen this for a lot of yours as you're working on your math here, that's what you needed to be focused on. The degree measure of an arc, bold word, vocabulary, highlight it. The degree measure of an arc is the same as the degree measure of its central angle. Did you catch that? The degree measure of an arc is the same as the degree measure of its central angle. This is important and deserves a star. The same is the key word. For example, if PRQ is the central angle and then its degree measurement is 30 degrees, well, the arc that goes from P to Q on the circle is also 30. 30 for 30. Okay, number one, imagine the face of a clock. Don't have to imagine, there it is. Consider that it is a circle with center O. Point A on the circle corresponds with 10 o'clock. And B on the circle corresponds with 2 o'clock. Draw a central angle. So we have to have some sort of a ruler device. Draw a central angle using the given points. And then identify the central angle you drew and its corresponding minor arc. So the central angle in this case goes from the center O out through A, goes from the center O out to B. Again, a central angle, which is actually a vocab word, right? We have central angle. We've been talking about this since 2 topics ago. A central angle is created when a point on the edge of the circle and another point on the edge of the circle form an angle with the center. There it is. There's our angle. So I've drawn it. Identify the central arc or central angle that you drew and its corresponding minor arc. The minor arc is the edge of the circle from A to B. It's the smaller section, the less than half of the circle section. So the first central angle is the measure. I don't need to write that part. I just need to write angle AOB. Right? AOB. And then that's the central angle. And the minor arc would just be AB. Don't talk about the letter O. It's not important anymore. But it's an arc, so put a little like part of a circle as the notation. That's the minor arc. With a protractor, ooh, they're being tricky on this one. Without using a protractor, determine the central angle's measure and then therefore the minor arc's measure because they're the same. So if you think about a circle as having 360 degrees, that's 360 little slices, little pizza wedges that go all the way around. But when you look at a clock, the clock itself, it's still a circle, it's still 360 degrees, but it's not divided up into 1 degree chunks. It's divided up into 12 sections. So from 12 o'clock, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. What is 360 divided by 12? From 12 o'clock, o'clock, not that part, to 1 o'clock. That is a degree measurement, just this much, right? Just that much would be 360 divided by 12. And so calculator-wise, 36 divided by 12 is 3. So I guess there's a 0 involved. It'd be 30 degrees. So therefore, every degree measurement, every hour-by-hour measurement on the clock is 30 degrees. 30 and 30 and 30 and 30. 4 sections of 30. 1, 2, 3, 4. There are 4 sections of 30 going from A to B. So the measure of angle AOB, which happens to be equal to the measure of arc AB, is 4 times 30, or 120 degrees. Now they say plot and label point C on the graph, right? So we're going to plot and label point C such that the arc BC equals the arc AB. And then we'll explain our reasoning. Well, I mean, if arcs are equal, then they have to have the same measurement. And for us, that's really easy to do because we want 4 hours of separation between our different things, right? 1, 2, 3, 4 hours separates points A and point B. So it's going to find 4 more hours of separation from B onward. 1, 2, here we go, 1, 2, 3, 4, right there. This is where C should be located. So that means BC is also equal to 120 degrees. And you know what? Because of the way it's positioned, AC is also 120 degrees. We weren't asked for it, but you know what? Why not provide it? That then means, right, that you can add sections of arcs together. Because if you add 120 degrees in this area, plus 120 degrees on this arc, and then you add 120 degrees on the top arc, you get 360. 120 plus 120 plus 120. 360. That's called arc addition, and we have a note card for it. The arc addition postulate. If the measure of an arc formed by 2 adjacent arcs, it's the sum of the measures of the 2 arcs. And so I wrote all of that on the back of my note card, and I even put the page number where I found it, the measurement equations that you're probably going to know. I drew an example. I've got B to A to C. I made those letters up depending. I used my compass, right? And I spun an arc around. And so therefore, I strongly suggest that you have this, especially because you're probably going to be asked to provide this statement on a Mathia assignment. All right, we are going to carry on with question 2 in the next video. Thank you for watching. Stick around, like, comment, and subscribe for more math hints. Yeah, bye.